Hello my viewers, welcome once again to my channel Israeli Math Concept. In this video, I'm going to solve this given problem on the board. The problem is related to direct variation. Let's read out the question first of all. The question says, if P varies directly as R squared and P is equal to 3 when R is equal to 4, we are asked to find the value of P when R is equal to 6. The first thing we have to do is to interpret this given question first of all. How do we interpret it? We are told that P varies directly as R squared. So let's put it this way. P varies directly. Of course, this is the variation sign. So P varies directly as R squared. So the next thing we want to do is to remove this variation sign. And how do we remove the variation sign? We introduce constant and also equality sign such that we have P is equal to K R squared. Remember, I want to repeat again. Whenever you put your statement in this form, P varies directly as R squared, and you want to remove the variation sign, just put your equality sign, then include your constant. Then the next thing we want to do is to make our K the subject of this given equation. And for K to be the subject, we have to divide both sides of the equation by the coefficient of K. And the coefficient of K is R raised to power 2. So we divide both sides of the equation by R raised to power of 2, such that R raised to the power of 2 will cancel itself, and we are left with our K. And the K is equal to P over R raised to the power of 2. Then remember, we are told that P is equal to 3. So we then say that when P is equal to 3 and the R is equal to 4 and R is equal to 4, such that when we substitute the values of P and R into this given equation, assuming we call this equation 1, if we substitute for the values of P and R into equation 1, we are going to have something of this nature. P is already 3, then we replace P for 3, all over R is already 4, then we replace R with 4, then raised to power of 2, and that is equal to our constant K, such that we have 3 over 4 raised to the power of 2 means 4 multiplied by 4, and 4 multiplied by 4 will give us 16, and 16 is equal to K, such that when we cross multiply K, we multiply 16, we then have 16K, and that is equal to 3. Of course, K is sent in as K over 1, such that 3 multiply 1 is the same 3. Then when we divide both sides of the equation by the coefficient of K, and of course the coefficient of K is 16, such that we have 16K all over 16 is equal to 3 all over 16. Then 16 we cancel out the 16, which is the coefficient of K, and we are left with K, and K is equal to 3 all over 16. This is the value of K. But the next thing we want to do before we'll be able to find the value of P, we want to establish the relationship between P and R. And what is the relationship between P and R? Very simple. From this given equation here, P is equal to K R squared, such that we have P is equal to, what is our K? Our K is now 3 over 16, 3 all over 16, then our R raised to power of 2. So this is basically what we call the equation of relationship between P and R. Then having known the equation of relationship between P and R, then we can now find the value of P when R is equal to 6, such that we now say when R is equal to 6, then we are asked to find P. So what is P? We don't know what P is, so we put question mark, such that we first of all list the equation of relationship, which says P is equal to 3 over 16, then R squared. This is basically our equation of relationship. Then we can now substitute for the value of R in this given equation of relationship, such that we have P is equal to 3 over 16 multiplied by, what is our r? Our r is now 6. Then we have 6 raised to the power of 2. Then we have p is equal to 3 over 16 multiplied by 6 squared, of course, means 6 multiplied by 6, which is 36. Then we have 36 here. Then let's begin to divide with the smallest value. If 2 divides 16, of course, we have 8. If 2 divide 36, of course, we have 18. If 2 divide 8, of course, we have 4. If 2 divide 18, of course, we have 9. Then you check if there is any other thing that can divide. I guess nothing else. Then we have that p is equal to 3 times 9 should give us 27. Then we have 27 all over 4. And basically, this is the value for p. So automatically, we succeeded in finding the value of p. All right, this is how to solve a problem relating to direct variation. Thank you for viewing. Thank you for watching. Remember to subscribe to my YouTube channel, Israeli Maths Concept, and also to follow me on Facebook so that whenever I drop a new math content, you will be notified. Thank you. Remember to share this video. Goodbye.